I guess I can go.
Great. You're very quiet.
Ah. Still very quiet?
Better,
Okay.
but a little quiet.
Not sure how to turn my volume up.
I think it's okay.
I can hear you pretty clearly.
Oops. Okay, so I'm doing the Bora Peak. I honestly haven't gotten as much. Oh, I didn't upload the new image. Anyway, I've gone through and I've done a few things additionally from what I had last time, and I've actually changed the fault in a couple minor places, but they're just very minor changes that I've done. I have the imagery to the, so again, we're here in Idaho. And this was the Earth Explorer, so I'm waiting on these to be georeferenced. A little bit of lag on my part in getting these to Chelsea and Ramon. So once I get these, then my next plan of action is to, I guess we just look at this, is to knock out all this alluvium with different relative ages and see if there's anything in there. Just from this more zoomed out image, there are some like lineaments. There's maybe a little scarp cutting across here, and then some of the toes or the ends of these fans have some interesting sharp edges in places that just want to try to do a little bit more investigating to see if that might be faulting or if it's just some other geomorphic thing. So let's see. Yeah, just like the typical scarps along these triangular facets that you see, and there's multiple left stepovers in the system. In the northern section, there's kind of this piece here, which I'm kind of thinking is some kind of landslide. There's a back-facing scarp, and depending on where you take this profile across here, there's it didn't show up as well here actually, but there's some of these other scarps, like this one, actually face back up if I took the profile just a little bit to the south or north. So I've kind of interpreted this as being some kind of landslide. It doesn't seem like the whole thing is just like catastrophically failed and there's not like a big rubble pile from what I see down at the bottom, but it does appear like these kind of smaller blocks are pulling away from this main headscarp. And then just wanting to, once I get the aerial imagery, being able to revise some of the fault locations and some of these stepovers. Just like I'm not totally happy about the way that this is currently drawn, and so just making sure that this is how I want it. And there's a couple other locations that are similar to that, but that's kind of where I'm at. I'm pretty happy with my main primary fault trace, and I haven't really discovered any major secondary faults yet that I've drawn in. Again, I've been doing kind of a lot of looking outside of the mapping area, trying to understand some of the alluvium and stuff a little better, just outside the edges, and then as well to the north. It's really interesting just to the northwest of this area, because the fault appears to splay at least into these two main splays, and so. Chelsea, I don't know if you want to give me another little area to tackle. I would be okay with that.
Yeah, I can do that. Probably looks like you've made most of the progress on this until I get the georeferencing done.
Yeah, and I think that that's just going to illuminate some more details that I might have missed in this DTM
Yeah, I think
especially with the alluvium, being able to see some color changes and stuff, or at least contrast changes between some of the fans, and maybe there's some other lineaments that'll show up in that imagery that I'm not seeing in this. So that's where I'm at. That's my goal.
All right, let's open up for students to make any comments or questions for CJ.
I had a question. This area, actually, this slide right here, where you're talking about the landslide kind of pulling it away from itself.
Yeah.
Where do you like, how do you see that? I see just kind of like these ridges, and I can see the polygon that you drew around there, but how are you kind of making that decision?
So this up here, I'm basically calling the headscarp, I guess. It's just interesting because there's kind of this stepping down with these back-facing scarps, and I feel like the only way that you would have that is there has to be some reason for all of the change in topography. Otherwise, I feel like the slope would just have a nice consistent slope going down.
Okay. And I can see how that would make sense with also those like triangular facets in that direction down there to like the south, the southwest.
It's just like the one area within the mapping area that has seemingly disrupted topography, I guess, relative to some of these other, like this is very typical with these triangular facets and these kind of linear ridges and drainages that are running kind of oriented with those facets, and that you see that along, especially in the south. The south doesn't have anything like this. The other thing that's kind of interesting about it is assuming that the fault does splay here, which I think it does, just to me, that also kind of indicates that it's very possible that you could have something like some kind of landslide here.
Did you make that decision on the fault splay based off of like the change in slope, like that dramatic change in slope right there, or were there other things like offset features or?
No, there's no offset features. This is a normal fault, and so I wouldn't expect like major lateral offsets by any means, but so more vertical motion occurring. And there's just the most striking feature is just the ridge front, basically. In the case here, I think the fault actually cuts across. There's a pretty nice lineament that cuts across the top of this, and then up to the northwest, it joins. It looks like the fault kind of bounds the edge of a alluvial surface that's up to the northwest, and then this one to the east just appears to kind of continue hugging this ridge front that stepped back.
Awesome.
If that makes sense.
Yeah.
And so it's mostly just the sharp ridge front is really the one thing that's keying me into putting a fault there more than anything else.
Awesome. Thank you very much.
I have a quick question, CJ. Have you been able to point out any obvious secondary faulting?
No, not really. I think there's maybe a couple things maybe in the bedrock that I might draw in, but no, I haven't. I'll be honest, I haven't really jumped into the secondary stuff yet. I was mostly focused on this primary fault. There's I don't know. Yeah, I haven't done it yet. Let's see. So I'm hoping that when I get the aerial imagery, it's possible that there might be something out cutting the alluvium. I really don't know. And some of the areas that I'm like, my eyes get keyed into are just outside of the mapping area. So yeah, I figure that I just won't really include them, but I'm kind of looking at them to at least try to illuminate some better understanding.
If you want to make your mapping area bigger, that's allowed. You can just redraw your polygon.
Okay, All right. Yeah, I might do
But
that
then
and
make
just,
sure, yeah, that it's important that we know like exactly where you are mapping. So just make sure you definitely send your updated polygon.
okay. Yeah, we'll do. All right. That's cool. And then I might actually just extend out to the west a little more to capture more of the fans, um, especially once I get that aerial imagery. And I think that I took enough of those photographs to the west that it should include that area as well. Those
I
ones that I sent you.
looked at the photographs briefly. They're actually not super well georeferenced in the Earth Explorer,
Yeah.
and they're
Okay.
bigger than they look like. So probably actually don't need to do all of them for you to get like coverage far out into the fan area, like on the other side of the road to the farms. Where,
Right. And I didn't want to zoom in too much because the Earth Explorer imagery is, like you said, is pretty detailed, and I don't want to bias myself. So I took all those tiles fairly zoomed out. So I did, and I didn't have like this polygon in the Earth Explorer. So I did my best to try to make sure I just captured along the ridge front where the fault is. But there might be one image or two images that are just outside of it.
yep. Do you
Can
have
I
a
talk,
comment, Ron?
maybe one quick thing? CJ, I really like the style that you're using. This is really sweet, you know, and a couple nice things. I like the kind of even coverage on the geomorph. And I like, you know, it just really right away, like it has what I call high clarity. Like I can see what you're talking about without having to squint or try to, you know, somehow worry about what's there. I totally see what you're doing with the triangular facets and the ridges and troughs. And I think they support your interpretation in a really clear graphical way. The other nice small things that you're doing that are detailed, that help build confidence, is the care that you have done with the discontinuous nature of the fault trace. So you sort of have variable quality from strong and primary to, you know, weak and primary to distinct. And then I like how you have the concealed where it's concealed in the active channels. So those things all together really are a great example of kind of what I think makes a good map is this and is that detail, but also kind of even coverage. Everything has about the same amount of information density as you move along the map. So that's quite nice. And so, yeah, hunting for some secondary features might be good. Because there's a lot of alluvial fans here, I kind of wonder if there's any distinctions you could make with the fan levels just to help, you know, characterize things. That'd be some polygons, but these fans are not as kind of well characterized as the ones in the other deserts that we work in. You know, this high desert or whatever, this is maybe not even a desert. These fans are a little bit harder to distinguish. But anyway, just wanted to compliment you.
Thank you. Yeah, I'm hoping that aerial imagery kind of there should be better, at least contrast for the fans. So I'm hoping that I'll be able to at least I have, you see I have my shapefile ready to go. So
Yeah.
I like that also, and on my presentation, I'll kind of bring that up, but the tonal contrast and alluvial fans give a good distinction between the two.
I had a quick question about your layers. How did you do, it kind of just looks like maybe like a title and then them, because I always just make individual shape files, but it seems like you have them all under like a shape file layer. Is there a way to do that the same way that Chelsea gave us the fault mapping layer? Is it when you make different strings and then you make the layer and then you identify it that way?
yeah, so I just go into, so like on this one, I double click on it, I change it to categorized, and then I can just add a whole bunch, and then you can just, you go in and number them, whatever you want them to be.
This is after you make the shape file. Then
Yeah, after you
right here,
create,
double click on it and you can add these.
Yeah, so
Uh,
first I make the shapefile, and then it'll just, whatever I title it, Bora Alluvium, and then I double click on the shapefile, go into the symbology, go change it to, I think it's usually on single symbol, so then I switch it to categorize. That's what I've been using. Then I can add however many I want, number them, and then if you double click here, you can give them some name, and then that, if you give them a name, then the name will actually appear in your legend instead of just the value, but the value
Gotcha.
will hold. So and then just organizing them so it's like 1, 2, 3, 4, 5 kind of thing.
Right. And then when you make any of the features, do you put in the number and then it automatically goes to what you have under the legend?
Yeah.
Yep. And I just added some extra little I added like a type thing that instead of, I don't add it into the ID, I just have it, I've kind of like customized it, if that makes sense. When I made the shapefile, I added like a comments feature and a type feature. And
Okay, thank you. That
yeah.
makes it look a lot more clear over there too. I like it.
And then these you can just, oh, whoops, let's just cancel that. But you can go and delete them and mess with them in the symbology tab as much as you want.
Another point, if I can interject on that, that's super useful is what Chelsea implied. You could build what CJ just showed, you could build your legend, and then once you have a uniform legend that you're comfortable with, you can use that same legend for all your maps using the same process that Chelsea showed you. If you can figure out where your legend is and then just have your shape files, you can use those shape files on every map.
Gotcha.
Yeah, you end up, you save it as a layer style.
Okay.
And then you open the shape file that you had and the layer style, and then you're good to go.
Okay. Thank you.
And also when you're in this, you can also double click on, oops, what am I doing? What? Oh yes, you can go here and you can modify your line in here. If you click on the simple, it'll usually say like a simple line in, this is a polygon, so that's why it was tripping me up. But yeah, so you can manipulate all the colors and all whatever you want in here as well.
Gotcha. Thank you.
All right, thank you very much, CJ. Let's move on to the next person.
I'll go ahead next if that's okay with everyone.
Great.
Sure.
You guys can see my screen, right?
Yes.
Okay, today is my second presentation on the Monte Cristo 6.5 EQ that happened this year. So one of the first issues that I wanted to address was I couldn't, like, I was struggling to create a DEM layer, but at least if I created a contour layer, I'd be able to distinguish some pretty evident profiles. So on Google Earth, I created a polygon set, and through that I was able to create a contour layer for my map for GIS. After I made the contour layer, I verified it just to make sure that I was getting at least relevant data. This is just a single example, but I did quite a few different areas just to verify the contour lines. The second phase of my attacking this project was to identify the drainage and urban areas. I went with the urban areas first because to me it was a little bit more distinguishable to the drainage areas and they all ran intertwined. So it was time consuming, but after a while I was able to identify some specific features in the north and southern areas. This is just an image of the urban layout with my contour map on it. When I moved to the second part of that phase, mapping the drainage, at this point it was kind of time consuming. So I noticed the ridge on the northern section that really caught my eye. As you can see, this is like my half completed drainage map, but I wanted to map out this northern area, but as I started mapping it out, I ran into a particular dilemma. And that dilemma was, is this a primary or secondary fault? To go about this issue, I decided to evaluate the entire area at multiple scales. Oh, and by the way, so the image here is of the set of triangular facets, the tonal contrast that kind of expresses that scarp across the valley right there. And so as I was mapping it out, that's where I ran into the dilemma. As you can see, originally I wanted to decide how to attack this problem. How would I be able to find the primary or secondary fault? There's so many things that run in my mapping area, different directions. So I started at 1,200 or 250,000 resolution, and I started mapping out pattern features that were basically tonal contrasts that at least at this level, would be able to identify, and maybe I could use these patterns and maybe find some unique traits within my own map. I also evaluated it at the 525,000 range, specifically because it gives you a good evidence of the San Andreas Fault to the west. These pattern markers are just for my own. I'm not going to be presenting them on my map, but it just gives you a good idea of how I was able to identify if I was able to, where's the primary fault. Finishing, I haven't been able to work very much this week, but where I'm at right now is I'm pretty sure I found the primary fault running along with several of the larger scaled areas faults that run in a general northwest to southeast direction. And the area that I was evaluating earlier, that's why it was marked in black, and I'm not sure if it's a secondary fault. Those are questions to be had in the future. I'm not sure if there's two different primary faults running through, but I definitely know that what I was observing in the north was not the primary fault line. And so as I'm going to be working in the southern area with a different contrast, along with using the change in my contour map. So that's where I'm at. Any comments, concerns, questions? So, before anyone asks, sorry for having so many slides. I just thought it was kind of important to get the point across, because as it stands, I don't have as much mapping as I would like to have done for my fault lines, but with with the change in environment in the entire area, it could be easily confused with what would be a primary, secondary, or a completely different fault structure. So.
All right, thank you. Jack, do any students have comments or questions?
What year was your earthquake at?
It was this year. It was this year.
Oh, okay. And you're using this layer. You're using like, this is way zoomed out of your map area, right? Like that, where all your lines are is.
Yeah, what you see, if you could see in that central spot, is my actual mapping area. Okay. But because, and maybe I can move to a different slide to show the area a little bit better. But if you could see, there's a lot of tonal contrast in this whole area that you wouldn't be able to distinguish. There's a fault line running in this area. In the south, there's a lot of distinct pattern that runs north and south. But then there's this ridge line over here in the north that runs northeast to southwest. So I wasn't entirely sure what is the primary fault structure. So going out to that larger resolution really gave me a good idea of how I just tried to pattern things up. What is the common pattern in the area that gives the primary fault structure within my map away.
Okay, cool. I gotcha.
Yo, did I do? I apologize for not having my video on that whole time.
Did you have a layer of faults? Maybe I missed it, but it seems
Yes,
like you're
actually,
talking about faults, but I wasn't quite sure which one that was.
Here's an example of just that initial area where I got the triangular facets with my geomorphic points, and then that fault mapping. I was able to, it was really easy transition from the stuff you gave us. And, you know, the inputs, you know, P for this one was P2. And I also have P1 in the center that really gave away a more distinct fault. It's a little harder to see because I haven't added more fault lines, but I really haven't done much mapping this week due to time constraints. As yesterday I spent time with my parents, but last week I spent a lot of time really trying to get down how is this environment, because it looks so interactive. There's so many different things going on. In fact, if I can point out something that I always takes my eye away is this lava structure here in the southwest. So yeah, because there's so much going on in this map, I really feel it's necessary to completely, like the contour, it took me, that was very time consuming, but I'm glad I got it done.
So the contour, you made it on Google Earth?
Yeah, so I created on this, if you see to your left, I created a set of lines in a pattern like this. I converted that, like it gives you a grid coordinate, and then you go to this particular website where you send your coordinates to, and it gives you an elevation profile for the entire area. And then you convert, it gives you a KMZ, and then you convert that KMZ over to ArcGIS, and you could build a contour map. Like it'll give you the lines. If you could see on this image to the right, you see all the pink lines. That's basically the image you're given. It's similar to a DEM file, and with that file you can build your contour lines, and that's what I did right here. All those are built myself. So
I think that's okay. The other way is probably much faster, would be to download the SRTM DM from Open Topography and then use QGIS itself to make the contour.
Yeah, I'm sending you the link right now to that. Hopefully it's in the right area.
Just as a note, although I do appreciate, I like your honesty that we said don't research too much about the area.
I really did take that to heart, to the point of where I'm doing, like, even trying, I refuse to look up the fault structure, even though I know what it is, the Monte Cristo fault structure. So I forced myself to understand the patterns in the area and really get it down to where, how does it interact with my map? What is the primary fault structure? What is the secondary fault structure? So I know I still have a lot to do, which this weekend is basically dedicated to it. But yeah, I'm really excited. I know I shouldn't have put that much work into, like, but I really think, what if you guys gave me an area in Antarctica that doesn't have any data?
Well, I was just gonna say, my only comment was, this is just for the language. This is not the San Andreas fault.
No, yeah, this area is not the San Andreas fault. It's much farther to the west. Yeah.
Other side, to the east.
Is the San Andreas to the east?
Oh, sorry. This is much to the east of the San Andreas.
Yeah, it's
and
much.
Their plate boundary.
Yeah, and like I said, I refuse to like research into any of this because I really want to like understand how to map at a larger and like a macro and micro scale. So.
Ramon or Rich, do you have any comments?
Well, one quick one. So I like your effort there, Jack. It's interesting to look at the regional context But one thing I would say is, I think I said this last time, is I really want to encourage you to tackle those alluvial fans. I didn't see any alluvial fan mapping yet. I think you're muted.
Yeah, sorry about that. I have started a little bit on it, but I exactly know what you're saying. Specifically, one of the more interesting things about the drainage in the system is if you looked at it without the contour lines, I thought that the drainage ran from the section of the north, and it ran to the west, but in fact it runs southwest to northeast. And so, yeah, that's actually something I'm really excited when talking about CJ's alluvial fans. That's something I'm excited to tackle myself. So,
Yeah,
Yeah,
I think. Go ahead, Rich.
I was just going to say, really look at the tonal contrasts with the really dark fans that are well incised versus kind of more flat, you know, tanner colors. Just really look at those tonal contrasts to really give you a better idea of where the different contexts are between the different fans.
yeah, that's something I've really enjoyed working in this desert environment is that tonal contrasts really give away, whether it be structures in the environment.
Mm-hmm.
All right, thank you, Jack. Let's move on.
I can go. I'm ready.
Great, Joe.
Okay. Let me share my screen and share screen. And where's the present? Okay, there we go. Wait, I gotta move this. There we go. My name is Joseph Powell. I am presenting on New Zealand and the 2016 quake. I am from ASU and an undergraduate student. I wanted to talk about this area that I focused on a lot. It's almost smack dab in the middle of my polygon, of my mapping area. It's right along the coast, and that's where I started finding the most activity, like the most kind of telltale signs of faulting. I have my main fault here where it goes under, and then it kind of recrops up, and then goes under again and comes back out. But this whole area down here was kind of more interesting and kind of confusing for me. I switched a lot of my certainty levels around in that area a lot. My next slide is the exact same area, just without the layers. So you can see like these kind of lineations that are going across the map, right? But as the secondary faults, and up here where the primaries are. And so I wanted to focus on, I think the next slides are on this little plateau right here. So I was looking at this area, and at first I thought that these kind of straight lines that go, you know, make almost right angles were just, you know, issues with the data. Maybe it was, you know, like different photographs, different like kind of resolution, or, you know, something. It just seemed very, you know, linear. And I started kind of looking a little bit closer at it, and I saw that this doing a profile, that this was actually a pretty big change in elevation. Right in here, these blocked up areas, that's all tree cover. And the same thing throughout here where it kind of goes down and over. It's hard to gain like too much elevation data, like to see if there's a slope change in this area. So I wouldn't really know what to put down for that. But I just found that this area was a little bit more complex for me and a little bit more deserved a little bit more attention. So let me move on. The next area that I wanted to show you is along that same fault system. It's right in here. It's right in here. Sorry, it's this secondary faults that I'm looking at. Right here again, I thought that these were just like maybe two, you know, data sets put together, and then that's just the straight line of the sewing. But you know, after doing another profile, which I should have included on this, but there's another elevation change. And again, I believe that this is mostly tree line, but yeah, I kind of, this right here as well, this this other secondary fault, that's kind of showing the same kind of attitude and same kind of trend as the lower one and the one on the lowest right-hand side. They all are within soldiered rows. They're all paralleled with the main fault trend up here, whereas this secondary fault seems to kind of bend off and get a little bit more parallel along this main fault where it changes the direction a little bit. I went a little bit further north, and right here, I wanted to, whenever we start, whenever I open it up for discussion, I wanted to discuss this area right here, this more northeastern area, because the fault seems to trend this way, and then right here, there's a big bend in it, and it seems to change strike to go more like northeastern, and these structures are something that I'm kind of confused about. These right here, these like ridge lines, they're right after that bend. And I'm wondering if that's like some kind of like releasing, secondary faults where they're releasing some of that energy that's still shifting this way. And they're kind of, faulting in this direction, to kind of like accommodate for that force. Right up here, there's a lot of scarping. There's a lot of, there's a lot of like lineation in this area as well. I wasn't quite as confident in the upper fault as I was the lower fault. The lower fault has much more dramatic scarp, and if I follow, I haven't sent any images over to be Google referenced, but if I follow it along in Google Earth, this area has kind of like a kind of predominant like tree line where it's just straight along where the fault is, and it almost seems like the trees are, and the trees are like following that fault in that area. Right here, I started kind of a new layer, I think sometime over the weekend, the human feature, where the roads are. Mostly because right in here, it starts to get kind of confusing from the hillshade where the roads and the topography kind of separate. So I, made this layer to kind of give myself a better idea of where that is. There's another pretty big fault, a pretty big scarp right here along this north eastern area that I found, and there's some secondary faulting as well. And it almost seems like it's like kind of bunching up right here where this road bends around. I'm gonna probably spend a little bit more time right in this area trying to piece that apart. Another image of for discussion without the lines on it. Now up here, this is further northeast, like towards the edge, the northeastern edge of my mapping area. Again, I mostly focused on the coastline. This was kind of a more confusing area for me. I know that right in here, right along here is where the actual coast is. But right through here, there's a lot of like rippling, it seems like almost like things are being squished together. And that's kind of like the idea that I'm getting, is that the tectonic setting is kind of smushing it together to create these like almost like compression ridges. That's kind of what I'm thinking these are. I wanted to bring it up in this time to where I could have some time to discuss. But I haven't mapped this area with very much confidence or at all yet. Just I wanted to see what y'all's take were here. I want to say that the fault is still along this area, but I haven't put that down either. Now this is the southern area. I wanted to make sure to spend at least like a solid like hour or two, looking at this area with the scope of mapping faults. I mapped all the drainages the other week, and this past week I've been mostly focusing on ridge lines, faults, human lineations, things like that. I found some scarps and some faulting in this area where the main fault seems to kind of step down right there, but that's about the only thing that I can really piece together. I find that the mountain ridges are difficult for me to map due to like the change, and like my eye just kind of gets lost in them. But yeah, this is so far like my progress on the southern edge. I haven't quite put the same amount of attention into the fault mapping down here, mostly just in the areas in which that I can see where there's like some funky stuff going on with the ridge lines. And that is all I have today.
All right, great, Joe.
All right, thank you.
Students want to ask some questions first?
So those, you were talking about those compression ridges along the coast.
These guys.
Yeah. So this is the ocean right here to the east, or
Right here where my mouse is.
yeah.
Yeah. This is that's all. That's mostly ocean water. Yeah.
So these are just to me, they're like very linear and they're all parallel, and it looks, to me, it looks very similar to like lake shorelines almost. Like they could
Yeah.
be maybe marine terraces or something, benches from terracing from different sea levels, maybe. I don't know, that may be another idea.
Yeah, that makes sense. I was also, I saw some of that right here. This is lower down that area with the road lines and things that I was talking about. That is kind of what I was thinking of, this line right here. I thought at first like, oh, that looks kind of like a ridge, but when I looked on Google Earth, like the shoreline was like right there. So I was like, ooh, maybe.
Yeah, so like just because of the proximity of the like shoreline, the ocean, and
Yeah.
then like they're all parallel and pretty linear. To me, it's an easier explanation to have them be some kind of wave cut benches or something like that, as opposed to a whole bunch of compressional ridges from faulting or tectonics. But I don't know. That's just my quick take on it.
Yeah, thank you.
What did it look like in Google Earth?
It was mostly like where the roads were. Oh, I can't. I tried to move it around like it was on QGIS. So where the roads were, which one is that? That's this guy. The roads cut through right here, and in the middle, this is all just kind of empty rolling hills.
Okay.
Yeah, like so, like this right here is. I think I turned off the human layer on when I took this snippet. But this right here is a road, and this right here is a road, as you can see, that cuts across. Right in between, it's all like, there's some trees like right around here, like this weird polygon area. But this is all like kind of rolling green hills.
Yeah, I'd be tempted to agree that it'd be hard to make a strong claim that many of these very low features that you see are tectonic.
Yeah, that's why I was pretty timid about mapping them that way. I was like, oh, I don't know.
And if there's any like maybe uplift or anything related to the subduction zone, then it would be very easy to like push these maybe wave cut terraces or something up to where they're being preserved like this and not getting eroded away.
Oh, that would make sense, yeah.
And you see that a lot, especially like on the west coast of, or on coast of California. You see that there's a lot of different stages and levels of these terraces, marine terraces, that have all they're there because that they're of the uplift that's occurring.
Yep. Yeah.
As we saw in Seattle.
That makes sense. And the only thing that like kind of confused me about it was this scarp right here, where you see where this like darker, where my mouse is. That's this guy. It's like about a 10-meter drop, and I was like, oh man, because like through here, right in this area right next to the ocean, that's kind of what I was figuring was going on as well. Was like that's probably water coming in, going out. Like the roads right here, so they would build it above, possibly above like the high tidal plane. But yeah, that would make sense. Like if it was pushing it further in, that it could definitely preserve that.
So I like how you've filled in a lot of your map, and especially in the low areas that we were talking about earlier, you have very even coverage.
Thank you.
I wasn't quite 100% sure about everything you had called a fault, but maybe that's okay. But it did look like some of your faults, you had mapped the whole thing as concealed. And that seems...
In here. Like this guy?
It's not quite the same time. I think it might have been a few slides earlier.
there's that one, and there is.
Yeah, maybe it was some of these.
You talking about these dotted lines right here?
Yeah.
Oh, okay. Yeah. See, I wasn't mapping that as a concealed. I was thinking of confidence level 4, like lowest confidence. But I could, yeah, like I should probably change that to 3 then, to the dash lines.
I don't know. These do look a little bit.
Yeah,
Like
you got to say
void.
it. I'm skeptical that those are false. Those look to me like swath boundaries in the laser scan, or these are photographic.
These are photographs, but you still see that, like right where your mouse is or was. If you go from one side of the where you map the fault to the other,
and it
like
even continues to the northeast
different.
across the drainage, so straight.
Mm-hmm.
You know, well, yeah, there where you map it, yeah.
Right there.
So, and the fact that it's a topographic break because it's an artifact in the way that the photogrammetry was done. It's like 2 photo edges or something.
Yeah.
So, I don't know. My suggestion would be to call it out, to map it, but maybe call it anomalous or some like I think it's a technical issue associated with the data, and it's worth indicating that you've observed it, but I wouldn't want anyone to confuse that with as a fault.
Yeah. See, that's why I was so timid to map it on that. That's why, put this as.
The other telltale sign that it's an artifact is actually that all these lineations that you've mapped are pretty parallel to each other.
Okay.
So it probably is related to the direction that the airplane was flying.
Oh, okay.
I will say that this thing is interesting. I don't know if that break right there.
Mm-hmm. Oh, this right? Yeah, this the one that like looks like it changes direction right in here. This guy?
No, that I'm talking about is inside the red that I just.
Oh, okay. Oh, I see. I see what you're saying. This line right here.
Yeah, why is that not something if the other one next to it is a scarp? Like these look pretty similar to me in their characteristics.
Oh, okay. Yeah. I guess I just didn't see that guy. That makes sense. Yeah, I think I was that this was one of the areas that I was wanting to get georeference. That I was going to send the Google Maps for it, and that's mostly because of these little skinny lines right here. I was so unsure about these guys. When I did the profile, it seemed like there was a hitch in the profile right along there, but that could be again due to the like you guys were saying, like the artifact. Would that also affect the profile?
Yeah, if there's a mismatch in the topography.
Okay, that makes sense then.
So we can georeference, but for these, you probably could find pretty well where they were on Google Earth without us georeferencing them, and just verify that you don't see these linear structures there.
Yep, makes sense. All right.
All right, great.
All right, thank you.
You, Joe? Daniel and Jackie left.
Can go.
Great.
Sure. Okay. From current. Okay. So this is my second update for the Kumamoto, Japan earthquake in 2016. So just to get everyone reoriented with this area, this is a lot of agricultural land here, which you can see all throughout the map. All these little squares are little parcels of land gridded off, and then you also see that there's this really high vegetation area. So a couple of the challenges with this for me so far have been not only trying to tease out what's happening in this highly vegetated area, but also try and figure out what could be happening in this agricultural land space here. So some of the challenges for this is I don't really have a strong geomorphic map because there aren't a ton of geomorphic features to map out, like really prominent ridges or alluvial fans. There's just so much vegetation here, it's hard to tease out where the slope breaks are and what's going on. But I started a preliminary fault map, which is kind of built off of what I showed last time, where I have this kind of sweeping feature, which is just kind of not very precise at all. It's just kind of where my eye was drawn to when I first looked at these images. But then these smaller features that are kind of running along the fault are kind of where I've started to zoom in at a more higher resolution and scale to see if I can see anything. So there's these really small, subtle, the small evidence of faulting and some fault lineations that run along this like main sweeping kind of just eyeball feature that I've kind of been noticing. And then I also kind of have been seeing faults going into, or fault-like features going in another direction. So I guess I'm kind of also teasing out where I could possibly be seeing secondary faults versus main faults. They're all kind of trending this northeast, southwest direction here. But I do have some kind of going in a slightly different direction. So trying to figure out what's going on there and if I'm seeing some secondary faulting or if it's just some weirdness that's in the landscape. So I know that last week there was some kind of revelations with different hill shades not being projected the best way. So I thought since this is my last presentation, I can kind of gauge everyone's opinion on just the data that I'm working with. So I'm just making sure I'm using all the resources that are available to me before kind of finalizing this. So this is the DEM, and I've been working with the ground, the unclassified, and the vegetation data set, and this is the full data set, not each one individually checked off. This is the whole thing. So when I've been starting this mapping, the best geomorphic feature that I have are the drainages. So I've kind of been spending a lot of time looking at the drainages and seeing what's going on. So kind of this is just this really zoomed in area of these main drainages that I've been seeing in the DEM. So I've been looking at this and using this main DEM as kind of a geomorphic drainage mapping layer. But I've also been using the same full data set to generate my hillshade, and it looks really strange. And I'm not sure if that's just the way it is or if there's something bizarre that I'm putting in when I'm generating this hillshade. I've kind of made a bunch of them and they all kind of more or less look the same. So I wasn't sure if this is just the product of a highly vegetated high agricultural area, or if there's maybe something I'm doing wrong. And here's some just preliminary fault lineations overlaid on the hillshade. And then finally, I have my slope map, which again is on the full data set. And I have been also flipping back and forth between just the ground and just the unclassified rather than the full data set. And I find that the full data set generally gives me more features to look at. There's a lot of blank spaces and gaps in the ground in the unclassified, whereas the full data set is more encompassing and fills in a lot of those areas. And then one other thing I wanted to ask is, so I've whereas the agricultural area is kind of limiting because I don't have these really nice geomorphic features to map, I was thinking that maybe I can use the agricultural area as to my advantage because it's so linear with all of these like really gridded parcels of land. I was wondering if there was a way that I could really zoom in on these gridded lines and see if there's any kind of offset or contrast that I can kind of tease out. So just zooming in on a couple areas, I started to see some lineations just in some tonal contrast. So you can kind of see them running in that same northeast southwest direction. And I think I have just a couple fault lines just to show you where those are. And I was just wondering what people thought about this and if this is maybe something that is valid or something that is not as valid. It's like kind of a trickier, it's so subtle that it's like you almost have to kind of squint to see it. So I was just wondering if this is something that's I should keep moving with, or if I should just abandon this kind of route. But there's a couple of other images where I've kind of see these lineations. They're just so incredibly subtle that I wasn't sure what to think of them. You can kind of see them if you squint, connecting some of the parcels that you see these linear features. So that's kind of where I'm at, kind of just open to thoughts and ideas on the data sets I'm working with as well as this method that I'm going with.
Thank you, Jackie. Any students want to ask some or answer any questions? So I guess you had two kind of bigger picture questions, right? One was looking at the data.
Yeah.
And your question essentially was, am I getting everything I can out of it? And these hillshades look weird. Is that because it's very agricultural and not always super high relief surface? Is that essentially your questions?
Yes, exactly.
Yeah, so I think as we discussed, making these hillshades here and deciding to use the classified or full data sets is tricky. It is a heavily vegetated landscape, and I'm not sure the classification was done all that well. So I think as you're doing, you should be flipping back and forth between the two of them.
Okay.
And as I think we've said before, looking at contour lines might help you as well.
Yeah.
Just to kind of filter out some of this, just like the kind of 5 to 10 meter scale modification of the landscape by people.
Yeah.
And your hillshades, like they should look a little bit different, right? If you have, if you put the light angle at the opposite side, right?
Yeah.
Cats are making trouble. Yeah, was that sort of answer the first part of your questions?
Yeah, definitely. And one thing that I have noticed is I have generated some contours, and whereas the full data set I find I'm more mapping on for the hillshades and the slope maps, the contours that are just generated on the ground, I find were actually more helpful than. So I'm kind of flipping around quite a bit between all of the sets that I have. These are just the ones that are kind of, I find more helpful generally.
I guess on the vegetation side, I'd be pretty skeptical about those small lineations through the farms.
Okay.
just because people are modifying this surface so fast that it's probably anthropogenic.
Okay.
If they were a little bit bigger, you could go back to Google Earth and like flip on the different time periods. It wouldn't surprise me if you saw them change a little bit. And they probably reflect small changes in elevation and therefore how water flows. But again, it's probably a fairly short-term feature.
Okay.
Modified by the farmers, maybe even seasonally.
Okay, that's good to know.
Had you made any progress on the faulting? It looks somewhat similar from
Yeah, it is
last time.
similar. Let me go back. I think this really large sweeping line kind of is distracting, but there's some smaller features that I've kind of started mapping in the south. I don't really have a zoomed in version of those, but they kind of run along this sweeping feature. But they're a lot smaller and they're pretty hard to determine. The confidence in those are pretty low.
Okay. Yeah, I think we discussed last time how you may want to not quite map quite so linear with high confidence, right? Because especially through these agricultural areas, you won't be able to see often the faults quite as well.
Right. Yeah.
And you may look across on the other side of the valley for other faults too.
Okay. And as far as like a geomorphic map goes, should I try to spend some more time trying to find things to map? Because I really only have mapped the drainages. I haven't really mapped anything else because it's just either vegetation or farms. So I wasn't sure if that's something I should try to zoom in
Again,
on
and
somehow.
there's in some of these higher relief areas, there is just more morphology that you can map, that you can see in these.
Okay.
In the DM and hillshades and so forth. So probably for having a pretty complete geomorphic map, or morphometric map, you do want to look at the mountainous areas in a little bit more detail as well.
Okay. Okay. Cool.
Any other comments?
Well, thank you for your suggestions, everybody.
All right, Daniel. We have Daniel today. Maybe not. Anyone see Daniel?
I don't see him on there.
I don't think he's present right now.
All right then. Rich, do you want to take the last 5 to 10 minutes?
Let's see. So as far as ridgecrest trenching goes, I only have about 5 minutes, so I'm not sure if that's enough to go over it in too much detail. I did want to say something about just presentations in general, and this is not to pick on anybody who presented today, but just in general, for everybody, all the presentations throughout the semester. Think about, I know it's hard being online when you're giving a presentation, but when you have your screens up and you're moving your mouse around, sometimes your brain is following the mouse and your viewers kind of are looking back and forth and following your mouse around, So to get around that, and which would make your presentations a little better, is to just slow down with the mouse and then maybe use your words to tell your viewers what you're going to do next, instead of like zooming in and zooming out. Just explicitly say, I'm going to zoom down to the southern part right now, and then do the zooming, so that your viewer's not your head's not bouncing around, trying to follow along. Because I know what it's like when you're working on your computer and you're thinking and you're doing all that, putting all the dots together in your head. When you're giving a presentation, when your screen's up like that, that's how it comes across. And so, think of us as being an audience, and you really have to draw our eyes to what you're trying to show, as opposed to just moving the mouse around and pointing, because sometimes it's hard to see the mouse, and that's okay. We can kind of find it if we look close. But if you use your words to sort of describe the exact part of the screen that you're talking about, it helps a lot. So you can say, up here in the northwest corner of the panel, this is what I'm seeing, and this is what I want you to see. Those sorts of things will help make your digital presentations better.
The other challenge, I think, is that there's a bit of a delay between what you show and then when the rest of the class sees it.
Yeah, and that's always an issue.
Even harder if what we see your mouse is 15 seconds back in time. One way maybe make things clearer would, instead of expect to move your mouse, you could animate a few arrows to appear, so that then it's just very clear exactly what part of your slide and what feature you are talking about.
Yeah, certainly. And hopefully we'll go back to being in person and giving presentations in person sometime soon, but digital presentations are not going away. You'll be doing those your whole career. So just use this as a time to practice that with a relatively friendly audience. Just remember that people are looking at what you're doing on a screen, and so you kind of got to slow down and really explicitly show.
And think about that for next week, but also in particular for the final presentations. And just having pretty simple slides with 1 or 2 ideas per slide, where you can easily show the audience the feature and the idea that you want to communicate.
Yeah, that's why I wanted to bring it up really for the final presentations. So even just some screenshots or still shots of what you want to show in your slide presentation, that helps, because there is a tendency to zoom in and out a little bit quicker when you have the controls when you're driving. So really decide.
The presentations should be completely on PowerPoint or PDF, but no showing directly from QGIS.
Right.
Thank you for the insightfulness.
All right.
Yeah, good advice, guys.
Are there any more comments or questions?
You said for the final presentation, we'd choose one or the other to focus on, and then just the report focuses on the second. But if you wanted to, could you kind of do like a little bit of each, or you'd like us to choose one or the other?
You can do a little bit of both also.
Okay.
But make sure you still kind of cover the main points about at least one of those. And if you want a little bit of comparing and contrasting, that's okay.
Okay.
What was your question, Rachel? I didn't hear your question.
Oh, for the final presentation, she said we can choose either our first mapping assignment or the second to be the focus, but I was just wondering if we could do a little bit of each, and maybe if they had like the same kind of faulting, to try to make some comparisons on them or something.
Okay, cool.
Yeah, that's fine, Rachel. I would just think about your outline pretty clearly before you make the presentation.
Mm-hmm.
And then I think it's a great idea.
Okay, thanks.
All right, any more questions? Comments? Everyone's excited for Thanksgiving?
Yeah.
Yeah, for sure.
Stay isolated Thanksgiving.
Similar to Rachel, I am also a Sagittarius, and so it's basically the best time of the year.
I'm a Scorpio.
Oh.
All right, well, I gotta get to class. Thank you very much for your time, and I'll be emailing you later today, Rich, to try to set up a meeting time tomorrow.
Okay. Yeah, that sounds good.
All right, thank you.
Thank you.
Yep.
All right.
All right, everybody.
everyone.
I'll see you later.